Hi everyone, welcome to video 4. This is going to start the chemistry stuff. Okay, we're going to move relatively quickly through this stuff since it's not a chemistry class. There's some basic concepts. I'll point out stuff when it's important. So matter is anything that's going to occupy space and has mass. Matter is composed of chemical elements, and it's from the Latin materia, meaning timber or substance. Okay, so let's talk about these states of matter. States of matter, SOM. States of matter are basically how fast are whatever is making up whatever you're looking at, how fast are those individual atoms or molecules moving. Okay, so solids move slow. Sorry, I haven't been changing up the colors. I didn't think of that until now. Okay, liquids. These are, we'll just say, medium speed. And then gas are super fast. But we don't really care about slow, medium, and fast. We really want to know, well, how can you identify them? Because just saying slow, medium, fast, everyone has different ideas of what that means. So instead we define these on how they take up space. So what happens to their volume and shape. So solids, these have I'll do a check mark for definite. So these have a definite volume and shape. So it doesn't have to be hard to be solid, right? The heart and liver are solid organs, but you could also say that. So the heart and liver, they might feel squishy and stuff, but those are solid organs. But then you also have human bones and teeth, which are also solid organs. But then you can think of other things that are solids, like butter. Butter's solid at room temperature. So it has a definite shape. It's not going to change its shape unless it's acted upon like butter. And it has a definite volume, so it's going to take up the same amount of space. Liquids, they have a definite volume. That's a check mark. Definite volume, but do not have a definite shape. So they're going to take up the same amount of space always that they whatever they're in. They're going to take up the amount of space, but they can change their shape. So what does that mean? If you have a glass of water and I have this much in it, that's 50 milliliters of water. But if I've changed the shape of the container, then maybe it's a little bit higher. So this is also 50 milliliters of water. So definite volume, 50 milliliters, but it's changed its shape depending on whatever container it's in. So a liquid will take the shape of the container it's in. When you pour water in a glass, the water is going to take the shape of the glass. And then a gas. Gases, we normally think if these are two walls, gases are just flying all over the place. So no definite shape or volume. We'll just do X for volume, X for shape. Alright, they're moving fast. Gases will take the shape of a container, but you can compress it. So if I have here, and I have these gases all over the place. So they are taking up the space of the container. They are taking up a shape. But if I put a piston up here and compress these down, then I have all my dots or gas particles down here. So this is a different shape that they're taking up now. And volume. Okay. So no definite shape or volume on those gases. Now let's talk about energy. Energy is the ability to do work, right? That's a physics definition. It's the ability to put matter into motion. So matter, we said, was anything that had mass, occupies space, and has mass. So basically, energy is the ability to move these masses. Let's talk about some different forms of energy. Potential and kinetic energy, you've talked about those in different classes. So that's stored energy for potential. Kinetic energy is the energy of motion, and you can go from one form to another. So if you're at the top of a roller coaster, you have a lot of potential energy, but no kinetic. And then as you shoot down that super big drop of the roller coaster, you're losing potential energy as you lose height, but you're gaining kinetic energy. All right, the ones we care about. We do care about those, but maybe some that you haven't had a definition before are chemical, electrical, mechanical, electromagnetic. I'll do that on another page if I don't have room for this. So chemical, these are the energies stored in bonds. This has to do with bonds. We'll talk about different bonds soon. So it's a form of potential energy. Chemical energy is a form of potential energy. When you break a bond, you release the energy. So we've talked about in different biology classes this molecule ATP. That was that adenosine triphosphate. So that's my adenosine, and then I have these 3 phosphate groups. So we've talked about splitting the bond of ATP, and that releases this energy. This is supposed to be a lightning bolt. Okay, so that's chemical energy. It has to do with the bonds. We store energy in bonds, and when you break those bonds, you get a release of energy. Electrical. So this is whenever you the flow of charged particles or ions. Okay, so this is movement. The one you should get really familiar with in this class is sodium. So when we move sodium from one place to another, it can generate electrical energy, which is another form of potential energy, and we can use that to do work. So when we flow sodium ions across the membrane, we'll get electrical energy, and we can use that to do work, send messages and whatnot. All right, mechanical, this is the energy of motion. So this is the energy that's required for movement. If you want to talk about the wind pressing on the blades of a windmill to make it move, as the windmill's moving around, spinning in a circle, that mechanical energy can be converted to electrical and then be used by humans. So this idea that we can convert between one form of energy to another is important. Just like whenever we talked about, you had that mechanical stimulus of someone pressing against you or something, but that's converted into an electrical signal that's sent to the brain. And then electromagnetic. I'll do another page. So electromagnetic is also called radiant energy. You have heat. This deals with heat. We talk about waves. Okay, so electromagnetic radiation, electromagnetic spectrum, electromagnetic energy. You've heard of all those. So you've got things like visible light, X-rays, gamma rays, microwaves. That's what this is talking about. Okay.